In this circuit, we are going to be diagnosing a problem with this splice left. And so here's my splice left right here. I have two multimeters that I'm using for this example. So this red meter lead is connected to this meter here on the outside left, and the black meter lead is also connected to this multimeter. And then these two meters, meter leads, are connected to this meter here on the right side. So what we're looking at here is currently there's an open in this node. And so we're going to figure out why we're getting these readings. We would expect that in an open, we would not have current flowing through this circuit. So some kind of interesting behavior that as a result of the meters that we're utilizing. So this number right here, 9.71, this is an indication in a voltage drop. This is an indication of a fault that is occurring at this node. So we know there is a fault. The thing that we don't know is the fault an open or is it high resistance? So right now we've identified this as the fault, and we might suspect it's high resistance because we're also dropping voltage somewhere else in the circuit. So let's just first verify that this is actually an open. So I'm just going to disconnect these leads right here. And I'm going to change to a continuity test. And we can see that we have an OL condition. So that's between these two leads. So this is actually an open circuit, and that's how I've set it up. So we'll go back to volts DC. Kind of another interesting behavior that when we change this to millivolts, our meter goes to an OL condition because the value that we're reading is too high for the current setting. But also we get illumination of this LED, which is very interesting because there's actually not really a continuous path through the splice left to get back to the negative terminal of the battery. So what's actually happening is we're coming to this switch right here, and the meter, the current is flowing through the lead and coming back through this lead, through the meter, back through this lead, and then completing the circuit in that way. Under most diagnosis situations, the meter leads in the meter has high impedance, which means that it's trying to prevent any negative effects when we're making actual measurements on the circuit. So when I go to measure the circuit using voltage, it's not supposed to interfere with that circuit. Because this is a very low current device, the LEDs, they're very low current. What we're seeing here is that we can still actually pass current. It's a significant amount that the high impedance is on the meter. I think it's around 60 mega ohms, but I'll post it on the video, the exact number. Okay, so how do we figure out if it's an open then, if we have this scenario? So one of the ways that we can do that is, first let's actually take a look at the current flowing through the circuit, just to prove out that we actually have current flowing through this circuit. So what I'm going to do is I'm going to disconnect this negative lead right here, and I'm going to change my right multimeter to read microamps because it's a really small amount of current. Make sure to put that on DC. And so this meter lead I'm going to stick right here, and this one I'm going to go right there in this position. And so let's actually swap those so we're have the correct polarity. So what we're seeing here now is that we're still reading a voltage drop measurement between this position here and this position here. We got an OL because once again we're in the millivolts range. But now that I've broken the circuit, now I'm forcing the current to flow through my right meter to be able to identify or measure the amount of current coming out of there. And the current that we're measuring is 260 microamps of current flowing through that circuit. So that's quite a bit. I mean, it's a small amount, but it's enough to be able to illuminate this light. If we place this back to volts DC, we can see that it's actually only about 1 microamp, which is not enough current to be able to illuminate this, although we still are dropping a 2.5 3 volts or so at that position. So this is just showing you that there is current flowing through the circuit. I can see the same type of measurement if I were to even just completely remove this component. So let's do that. So I'm going to remove this so there's no action happening between that splice. And then I have these multimeter leads that have a banana jack. And so this is just going to plug right in here. Okay, and then this meter lead I'm just going to stick inside this part right here. And we can see that even without that node in place, that we are in fact going through the multimeter here on the left, even though it has high impedance, to be able to drop the voltage. So we can see that again with the millivolts. Here we have this light illuminating, and so current is flowing through this meter. So this type of behavior really is only going to happen when we have a very low current situation with LEDs in the circuit. Okay, so let's go back to our voltage measurement, and let's determine how we figure out if this is a high resistance or an open. So I'm going to place my node back in there. The node is still in the open position. And the best way to do this is I'm going to take my black lead. So this is my black meter lead from this left meter. And I'm going to place it on the negative terminal of the battery. And then my red lead, I'm going to place on the positive side. So here we see that we have 12 volts. When I move this meter down to each of the individual positions, so now I moved it to this position, this 12 volts is an indication that I have continuity between this point here and this point here. This is essentially the same as the positive terminal of the battery. Okay, so let's check right here. Looks like we've got 12 volts right there. Here we have 12 volts. And then if I measure this point right here, notice that we've gone to 0. There is not continuity between this position here and this position here. So 12 volts there, not 12 volts right there. And there's no change even when I disconnect the meter, disconnect the node. All right, let me swap this out and make this node be high resistance now. I'm going to plug it in. So we see right here that this light is illuminated. That should help us, without our meter touching anything, that should help us indicate that this probably is high resistance. But in order to measure that, we're going to do the exact same test. So I've got black meter lead here, red meter lead here, and we've got 12 volts right there. And then when I check this side, we have 3.6 volts. So just to be sure, I'm going to disconnect this. So remember, when we don't have current flowing through the circuit, we can't have voltage drop. I was measuring this plugged in, so I had some voltage dropping right there. When I make this measurement right here, you can see that we have 12 volts, which is an indication that there is continuity going back and forth. So hopefully this helps you to identify or be able to figure out the difference between measuring a high resistance fault and an open fault in a circuit with a low current application.